I'll do this twice just to, if someone's behind. I just want to keep going. I don't want to keep you guys from the Super Bowl today.
Thank you.
Later, but there's a lot of prep time, right?
Not great.
Okay, so what we want to do is trim. So your x or trim about the y and the z should be 0 already, unless you have some kind of incidence on your vertical tail. Then you would want to trim out for that. The only reason for that sorry. Let me correct myself. You would trim out. You would trim out in the yaw if your tail was not designed to counteract the propeller normal force, right? You want to add some kind of incidence, and that should neutralize each other at the cruise state. So you can trim about the y and the z, but it's not going to be super needed for all of your analysis. The biggest one is your x, because that's your cruise state. You're going to apply straight level. Okay. So that's what we're going to do here. Click the trim about the x, or sorry, not the x, the y. I totally did saying the wrong thing. So y-axis, which is pitch, right? Click next. Max iterations, this is how many times it's going to try to calculate and converge down to final point. And the tolerance is what that point is. So how off from what the values it needs. So we have a weight of 2,450 pounds. We need lift of 2,450 pounds. So if we do a lift tolerance of 20, it might not make exactly that for 2,450. It might be 2,430, 2,470. Okay, so it might be higher. With it lower, it's much more representative of your trim state, right? Because if we're 1,000, if we're, I'll say 50 pounds lower or higher than what our weight is, our trim of our elevator and trim state in general is way off. Okay, so you're not producing the same lift you need for that flight condition. Your induced drag is off. The moments are off, so it really throws everything. So keep it low. 1 is good. If it doesn't converge, there's more than likely an issue with your overall design, not the method of analysis. Okay, at this point. Iterations, let's change that to, shouldn't be bad, but just do 10 for now, and we'll see if we can get it. Click next. You can save the file and name it whatever. It'll name it automatically the name of this file, or you can change whatever flight condition you're in to that name. Click next, and then you'll click trim. Hopefully everything goes nice. You have your moment about your x, y, z, and then you have your lift lines here. And you can see the red, the solid red. It had an initial guess. It changes parameters, and that parameter is primarily your elevator deflection, and it sees what happens there. Okay? And now the next iteration after that second one, so the second iteration we had too much lift. Third iteration we had around what we needed. I can't really read that number. And then again, we were a little too high. So that's the iterative process. It takes into account your moments and your lift, and tries to converge both of those. Okay. When you click summary, just to check it out, you can see what kind of deflection and angle of attack you're at. Right now, we trimmed, and he may be there, but the model is really weird, so I can't promise anything. But I'm at an angle of attack of 0.77 degrees, and elevator deflection of 4.6 degrees. Okay. So this is actually really good because it tells me there's a visualization issue in surfaces, not an overall CG calculation issue, right? Because we're able to trim. Right now our CG is way behind our neutral point. Typically, we should not be able to trim out like that. Okay?
Mine never converged.
It did not converge?
Those two lines, it doesn't look like yours. They just split and they just stayed on.
Yeah. All right. So Let me check it out real quick.
What is it?